You drive a cement truck. The amount of cement in your cement truck T minutes after it begins pouring. It's difficult to read. This is the fourth time I've started this video, just FYI, because I keep mispronouncing cement and truck. I call it trunk. Anyway, it begins pouring cement. So you've seen the cement trucks. I'd draw one, but you know what they look like, I hope. Google it. So they pour out cement out of the back and this thing keeps spinning. So basically the number of cubic meters of cement is going to continually decrease. So it begins pouring cement modeled by this function. So this is how much cement is in the cement truck. It's measured in cubic meters. It's a matter of volume. So how much cement is in the truck at t equals 0 minutes? This was right before you began pouring, so like they just opened the spout, still full, and how much cement is in there. Use correct units. So what we're going to do is basically find C of 0, and that would be 16 e to the negative 0 over 10, which is 16. Okay, 16 what? Use correct units. I'm dealing with the volume of cement, and so far, no integrals, no amazingness, just 16 cubic meters in my cement truck. Okay, what is the average amount of cement? Whoa, average amount of cement. Okay, we read the word average sometimes and we think, oh, I need to add a bunch of stuff up and divide. This is a special formula. You also might think of average rate of change, like slope on an interval. No. How much cement? Like the average amount of cement in the truck during the first 10 minutes. So we go back to this idea of the average value of a function. Average amount of cement follows this idea. The integral from 0 to 10 minutes of our function, C of t, we'll just call it that. You don't have to write the formula. But we would divide by the width of the interval. That's what I'm dealing with. So this is a calculator issue, so yeah, good luck trying to integrate that, do things by hand. I mean, you can integrate it relatively easily, but use substitution. But just, let's not. This would be a calculator active type question. So 1/10, we'll call it 0.1. Math 9 from 0 to 10 of C of t. C of t is 16 e to the negative t, call it x, over 10, and dx, dt technically. Whoops. I say whoops because I left something off, and this is a big whoops, dt. I need that. That is part of the operation of what's going on. So 10.114, use correct units. Okay, average amount of cement, it's still a quantity of cement. So for the first 10 minutes, I have on average 10-ish cubic meters of cement in my truck. So I open the hatch, I begin pouring, 10 minutes have passed. I started with 16, I end with, well, less than this, but on average, I have 10.114 cubic meters. At what time t is the amount of cement in the truck equal to the average amount of cement in the truck during the first 10 minutes? What? Okay. At what time, final answer will be t, what time t is the amount of cement in the truck. So when does this equal the average amount of cement in the truck during the first 10 minutes, which you just found to be this? Average amount of cement in the truck during the first 10 minutes of pouring was this. This is what you're looking for. That's it. And we're going to solve it. So let's do it. So 16e to the negative t over 10 equals 10.114. And we can solve it by hand if we wanted to. I'm not. I'm going to go crazy on you here. Let's grab a calculator. Let's solve it the old-fashioned, new-fashioned calculator way. 16e, so that's the ln button, second ln, negative x over 10, and then 10.114. You know what? You know what? Do you know what? I know what. I'm going to get technical about this. I really want to get technical. It's going to be great. So let's quit. No, don't quit school. The last thing we typed was this, right? By the way, I just pressed second and enter. I just wanted you to know that. Second and enter, and it pulls up the last entry, and there it is. There it is. So this is like super accurate, right? So 10.114 is rounded, and it's best to carry decimals with you as you go. So I'm going to store that as whatever you want to call it. I'm going to call it C, we'll just call it C. And so from now on, for the rest of this calculator's life until I reset the memory or redefine it, this is C. So I'm going to go to y equals and set it equal to C. Now I had 10.114. This is more accurate. It may not make much of a difference, but it might make just enough of a difference to where it would impact my answer and the accuracy of my answer. So I want to know what I could do to solve for t. You could divide by 16 and take a natural log. Yes, 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 yes. Go, 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 go. I want to do it this way. Let's go to a standard window. And you're going to see the c function, which would be 16e to the negative 10, t over 10. And then you're not going to see this. And the reason you're not going to see it is because your maximum y value is 10, and it's slightly above that. So let's adjust the window. And I want to go a little bit higher. Let's go enough higher to where we can see what's really going on. Let's go to 12, 15. Let's go 15. Let's go 15. And I probably don't need to go all the way down to negative 10, but whatever, we'll stick with it. So now I'm seeing a little more of the c function. There it is. And there it is. And I want to know where they meet because that's the t value. And again, we could have solved this by hand using a calculator. But we're going to find that, and that is second in calc. I want to find a point of intersection. First curve is the blue one. You don't see it. It's way up here, but press enter. Second curve is the red one. Not very curvy curve, but there we go. Guess. Oh, you guess. So 4.587. And at what time t? We're going to call it that many minutes.